Now I'm going to start this video with a little demonstration. So yeah, I have this maybe around 50, 100 gram, probably less than that, a very, very light pencil. And I have a much heavier metal water bottle. We all know that this metal water bottle is heavier than this pencil. Okay, it's not a surprise. Now I'm going to drop both onto my bed, and I want you to predict which one is going to land first. The heavier metal water bottle, or this lighter pencil? Let's have a look. So I want to make sure that I'm dropping both where the pencil is in line with the base of this bottle. It's about there. And I'll drop it from as high as I can, just about you can see. I'm not doing any tricks here. Remember your prediction. Now if you see from that video, that little demonstration, they both landed at the exact same time. And you could probably slow it down, and then maybe, because of the unevenness in the bed or whatever, maybe one looks like it hit earlier. But to the raw, naked eye, it looks like they both hit the bed at the exact same time. So today we're going to be looking at Newton's laws of motion. And the first one we're going to actually look at is the second law of motion. So Newton's second law. Now Newton's second law is, let's say you had a body and there were a couple forces acting on it. Let's say a 30 Newton force this way and a 100 Newton force that way. Let's say the mass of this body was 100 kilograms. Newton's second law states that the resultant force, F, is equal to the mass of the body times its acceleration. So using this equation, we could work out the acceleration of this body. We know that the resultant force is, 100 minus 30, that is 70, equals 100 times by A. So if you calculate A, you'd get 0.7 meters per second squared. So in words, Newton's second law is, if there is a resultant force, then an object will accelerate in the same direction as the resultant force. So let's look at that, what that meant with our experiment at the beginning. So you had a metal water bottle, let's say it was maybe 300 grams. Let's say we had a pencil which I dropped at the same height, and that was, let's say, 50 grams. Now in an ideal case, which is going to be a lot of what your questions in your papers are going to be based on, we're going to ignore air resistance. So the resultant force acting on each of these bottles are just their weight. And in this case, mg for the bottle is 0.3 kilograms. So the mass is 0.3 kilograms times by g, which is the gravitational constant. And in the case of the 50 gram pencil, the mass is 0.05 kilograms. So the weight is 0.05 times g, which is just 9.81. So if we wanted to find out the acceleration for each of these objects, we look at the bottle. We know that F equals ma, so if we rearrange it, we get A is equal to F over m, where F is a resultant force. We get 0.3 g over, the mass is 0.3, so we just get g. And for the pencil, we get A equals F over m, which is equal to 0.05 g over the mass, which is 0.05, which is also g. So they have the exact same acceleration, which is why they both dropped and fell at the same time. Now there may have been a slight discrepancy due to air resistance, but in the ideal case, if this was done in a vacuum, they would both fall and hit the floor at the exact same time. Now Newton's first law is actually a special case of the second law, and what it considers is, what if the resultant force on an object is equal to 0? And this sigma sign here just means the sum, so it's basically the sum of the forces, so this is representing the resultant force. If that was equal to 0, then F equals ma. If 0 equals ma for an object that has some mass, that means that A must be equal to 0. So when there's no resultant force acting on a body, there will be no acceleration. And what that means is, if the resultant force is 0, acceleration will be 0. Therefore, the object will continue at its current velocity. Or, if it was never moving to start off with, it will remain stationary. So if an object was moving at a certain velocity, it will keep on moving at that same velocity. Or if it was standing still, not moving at all, if the resultant force is 0, it won't be moving. Now Newton's third law is a bit different to the other two. Now Newton's laws will never really come up as a question on their own, but the concepts will be integrated into certain questions. Newton's third law states that every force has an equal and opposite reaction force. So let's look at you standing on the earth. Here's you, here's the big old earth. And I know this is definitely not scale. If you, being the person you are, and due to gravity, you obviously have some weight that's pointing down towards the earth. Newton's third law states that there's an equal and opposite reaction. And you might think, well that means that the earth exerts a reaction force on me. No, it does, but that is not the equal and opposite reaction to the weight force. What actually happens is you pull the earth by the same force. So the earth is attracted to you by the same magnitude as your weight. And I might think, hang on, then surely the earth would accelerate towards me. Well, let's have a look. We know that for you, the resultant force is equal to F equals ma. Your acceleration will be mg over m, which is g. Now for the earth, its acceleration is mg over the mass of the earth. And the mass of the earth is about 10 to the 24 times greater than you. So it's 1 followed by around 24 zeros heavier than you. So the acceleration is roughly g over 10 to the 24, which is incredibly small. So that's why the earth doesn't actually move towards you. So this equal and opposite statement means that there's a force acting between two bodies. One body will exert a force, body A will have a force exerted on it, and body B will have the exact same force in the opposite direction exerted on it. So Newton's third law acts on the two different bodies. It's not, in the case of you standing on the earth, the equal and opposite reaction to your weight is not the reaction force. The reaction force supplied by the earth is not always equal and opposite, and you will find that out in certain other questions. Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.